Welcome to Mathenatic. In this video, we'll find the derivative of fx from first principles, where fx is equal to 3 minus 5x squared. When they ask you to find the derivative from first principles, you would need to use the equation of limit of h towards 0 for fx plus h minus fx over h. Now, what I would like to do is actually find fx plus h first. So to find fx plus h, I would replace x in my equation with x plus h. So to do that, we'll have 3 minus 5 x plus h squared. Next, I'll expand. So this will become 3 minus 5 times x squared plus 2hx plus h squared. Now, here is where people normally make a common mistake. Sometimes people say that x plus h squared is equals to x squared plus h squared. But that is a mistake. Remember that if I have a bracket squared, that's the same as saying x plus h times x plus h. And when I FOIL properly, I'll end up with 3 terms. Now I can remove the set of brackets by distributing the negative 5. So that becomes 3 minus 5x squared minus 10hx minus 5h squared. Again, a common mistake that people make is they say this is 3 minus 5 and they make that negative 2 and then they substitute or distribute a negative 2 in. That's also incorrect. Remember, this 3 is standing by itself and the negative 5 is connected to the brackets by multiplication. So I only need to multiply out the negative 5. Now that I have fx plus h, I will substitute both fx plus h and fx into my formula for the derivative. So therefore, f prime x is equals to the limit of h towards 0 for fx plus h, which is 3 minus 5x squared minus 10hx minus 5h squared minus fx, which is 3 minus 5x squared over h. So I want to show you that when I substitute, we have fx plus h first, then minus f of x. And when I take away fx, I actually put that equation in brackets. Because when I distribute this negative now, or negative 1, you would see that negative 5x squared will actually become plus 5x squared. Also notice that we keep the limit in front up until we substitute 0 into our fraction. But right now, I cannot substitute the 0 into my fraction because I will then divide by 0. And we are not allowed to divide by 0. So I need to simplify further. So this becomes the limit of h towards 0. And in the numerator, I have 3 minus 5x squared minus 10hx minus 5h squared minus 3 plus 5x squared. So remember, we are distributing this negative 1. And when I multiply out, it's negative 1 times 3, that's negative 3. And then negative 1 times negative 5x squared, which becomes plus 5x squared. And this is all over h. So now we can add or subtract like terms in the numerator. So 3 minus 3 is 0, minus 5x squared plus 5x squared is also 0. So I'm only left with negative 10hx minus 5h squared. So if you would like, you can write that down as this is the limit of h towards 0 for negative 10hx minus 5h squared over h. And what I want you to notice now is that we have a common factor of h in our numerator. So I can factorize. I cannot substitute the limit of h towards 0 yet because I would divide by 0. So taking out a common factor of h, I'll have negative 10x minus 5h in the numerator over h. So now we have h over h, and these two would cancel out. So therefore we have, this is the limit of h towards 0 for negative 10x minus 5h. Now I can safely substitute h with a 0. So we'll have negative 10x minus 5 times 0, which becomes 0. And therefore my final answer would be negative 10x. So that is how we find the derivative from first principles. So remember to use the formula and notice that I'm keeping the limit in front of my fraction up until I substitute h with 0. Then only can you remove the limit. And it was only safe to substitute h of 0 in my final step, because before that my denominator would have become 0, which is an undefined fraction. Thank you for watching. Please like this video and subscribe to the channel for more hints and tips and tutorials on mathematics.